Yeah, hey everyone, what's up? Today we are looking at the problem maximum number of ones in an array. Basically, what we are doing in this problem is we are supposed to change the zeros that are there in an array into one, uh, given the number of zeros that we can change actually. For example, we will be given a k. So k is the number of zeros that we can change into one, and we need to change those zeros, which in result will form a subsequent, uh, which will in result will form a sub array with subsequent number of ones, which is the longest. Basically, we need to make a longest array containing subsequent number of ones. So in such a manner we need to change zeros into ones, given the number of zeros that we can change. As given in the question, given a binary array containing only zeros and ones and an integer k, you are allowed to flip at most k zeros to ones. Find the maximum number of consecutive ones that can be obtained in an array after performing the operation at most k number of times. So, what is the first solution that comes to mind? Like let's check the maximum number of like let's find all the subarrays and see the maximum count that we can receive. Basically, what that means is we can actually check all the subarrays that we can form inside an array, inside this array, like 0 1. Like we can compare the number of zeros in this, like it is less than 2, so this is one possibility. Then we will include these two. This is also one possibility, because the number of zeros is less than the number of k's that we are provided with. And after that we increase the number of the size of the subarray. So now it starts. Now this also helps us make the longest. Now this also helps us make the longest subsequent number of ones in an subarray. But this approach is actually very time consuming, and it would give us about the time complexity of o raised to the power n raised to the power 2, O1 square basically. It will give us the time complexity of 1 square. So that's why we will not approach with this solution. What we will actually implement is the floating window solution. So what is a floating window solution? In this, we basically have two pointers, a left pointer and a right pointer. In this, one pointer is fixed. In our case, it would be the left one, and one pointer is dynamic, which moves. In our case, which would be the R right pointer, and there would be a count COUNT, which would be 0 initially, but we will always check if it is less than the value of k, and it should always be this. So this is actually what the floating point algorithm is. In this, what we do is, based on the condition, we either move the right pointer forward or we move the left pointer forward. In our condition, if the count is less than that of k, we will move the right pointer, and if the count exceeds than that of k, then we will move the left pointer, and if the left pointer encounters a 0, we will do a left plus plus, and we will do a count minus minus, and will proceed with the increasing r towards the right. So that's how this problem is going to function basically. So now, is there anything else that I would like to explain in this? Yeah, I guess not. So this let's go to this code. Like, this is the code. First of all, we have associated the allocated a 0 to the right, 0 to the left, and a count is obviously 0. And we will also indicate a maximum length. The maximum length is basically going to increase whenever we will encounter a array, uh, a floating window, which will fulfill this condition. The count of zeros in that subarray should, in that window, should be less than or equal to that of k. then we will increase the count in max length, and we will obviously have the size of the array, basically vector in our case. So now right being 0, we will obviously want the right to be less than that of the size of the array, and we will increase right. And if the right is equal to 0, we will increase the count plus plus. The count will be increased in the marking that marking that we have encountered a 0, and this count should basically be less than that of this k. And if the count exceeds k, if the value of the count exceeds k, we will check if the left pointer in this array is at a 0 or not. If it is at a 0, we will decrease the value, we will decrease the count, we will decrease the value of zeros that are there in the window. So if once the number of zeros is decreased, we can proceed with the normal operations, and we will again dynamically move right to the next pointers, and so like this. And once that is done, yeah, we will obviously do a left plus plus, because that's how floating point window will work. No matter if it is a 1, if it is a 0, if the value of count is greater than that of k, we will iterate the left pointer forward, and we will always keep on checking the max length. The max length being the length of the current window and the length of the previous max window that we found. For example, if we found out that the value of the previous max window was 3, okay, and the value of the current window that we found out being right pointer minus the left pointer plus 1, because the indentation in C++ is 0 based. So if this happens and we found out of 5, then we will associate this 5 to the max length variable, and once this for loop is done iterating, we will return the max value. So now after explaining this, let's try submitting it, see if it fulfills all the thresholds. Yeah, so here's our streak. Thank you very much. Yo, it's your boy Tyson. Yeah, welcome to Rap Caution Tree. Yeah, just like Chinese yuan, find max number of 1s, 0 and 1s in an array, doing disco dance, making trance under Eiffel Tower in France. Come on, let's give this problem a chance. Yeah.